Number 15, A. Distinguish between the first, second, and third ionization energies of an atom. Well, the first ionization energy is the energy required to remove one electron from an atom, which is neutral, meaning no electrons have been removed from that atom yet. So we're removing the first electron, first ionization energy, first electron. Second ionization energy is the energy required to remove an electron from a +1 ion, which means there's already been one electron removed, so we're about to remove the second electron. Second ionization energy, second electron. Third ionization energy is the energy required to move an electron from a +2 ion, meaning we've already removed 2 electrons. We're about to remove a third electron. Third ionization energy, third electron. B. How do the values of successive ionization energies compare? Okay, and so what's being asked here, if we know the values for the first ionization energy, second ionization energy, third ionization energy, which one's going to be larger? Well, the reality is that each successive ionization energy is larger than the preceding one. Okay, meaning out of all the ionization energies, the first ionization energy is going to be the smallest. The second ionization energy is always going to be bigger than the first. The third ionization energy is always going to be larger than the second. The fourth ionization energy is always going to be larger than the third. The fifth ionization energy is always going to be larger than the fourth, and on and on and on. Let's see, why does this occur? Realize each successive electron must be removed from a particle with a greater effective nuclear charge. Each time we remove an electron, each time we ionize the atom, we are only removing electrons. We are not removing protons. And so the total amount of nuclear charge is staying the same. But we are removing electrons, therefore reducing the amount of shielding that the other electrons are experiencing. And if we lower the amount of shielding, those remaining electrons will feel a greater nuclear charge. Now, the nuclear charge is not changing, but they'll get to experience more of it. They will be affected more by it. And that's why we call this the effective nuclear charge will increase. The symbol that you'll see in your textbook for effective nuclear charge is a capital Z sub F, EFF, effective.